Hi, my name is Meyer, and this presentation covers everything you need to know about my honours project, namely, evaluating machine learning as a tool to improve speech recognition. This presentation will include an introduction, methods used by the program, feature extraction techniques, a discussion on neural networks as well as the genetic algorithm, a practical demonstration, relevant results, and a conclusion with closing remarks. The focus of the study was to assess the impact of machine learning algorithms on a speech recognition system. The system I developed was a digit recognition system, and the machine learning algorithms assessed were two neural networks and a genetic algorithm. Okay, so here we have a flow diagram describing the methods used by the program in order to successfully recognize the spoken digits. We start off by importing the sound, which is to take the acoustic word spoken and to digitalize it. After that is done, we need to segment the continuously spoken digits into separate words in order to classify them separately. If you take a look at the graph above me, I use this as a tool to describe what the program actually does, which is to implement a threshold to distinguish between what is seen as background noise or background sound and what is spoken word. The next step is to extract features from the spoken word. Now, feature extraction is explained more delicately in the next slide. However, what you need to know is this involves doing a Fourier analysis or extracting a power spectrum of some sort from the word. So after the feature extraction is done, we move on to the matching or the classification step. Now this involves taking the features extracted from the spoken word and comparing it to features extracted from the training data set. Now the training data set is basically a database of 50 or 100 instances of each word, and feature extraction is done on each instance, and the result is an averaging out or even implementing an algorithm on these instances in order to improve classification. So feature extraction is a sort of dimensional reduction of the signal, which is an informative and a non-redundant way to generalize the specific features inherent in the signal. As you can see, I've chosen to use two feature extraction techniques quite popular in speech recognition systems, namely frequency septual coefficients and time-dependent frequency analysis. Next up, I'd like to show you some code regarding feature extraction and classification of the system. Alright, so now we're in MATLAB, and the function we're looking at extracts the features for each word in the training data set. The first four runs for each instance of the words 0 to 9. The inner loop runs for each instance of the words within those classes and finds the WAV files, as you'd expect. From that, we extract the frequency coefficients and the spectrograms. At the end of that run, we find the average of each of the extraction techniques, and that serves as the general matrix for that specific digit class. The next function to look at is the spectrogram correlation function, which is one of three correlation functions which assists in the classification of an input word to the training data set. In this case, we make use of a cross-correlation function that determines the error rate between the spoken word and a certain class in the training data set. Using this error rate, I am able to create a probability array which would assist in the ranking of the spoken word to a certain classification class, and thus determine which word was spoken. Now that we have a clearer understanding of how the extraction techniques as well as the classification techniques within the system works, I can go on to explain the machine learning algorithms and how they assist to improve classification within the system. I'll start off by describing neural networks, this being one of the more popular or most popular machine learning algorithms used in classification problems. The first neural network I used was a feed-forward neural network described by the diagram A, as well as the pattern recognition network described by the diagram B. Now I'd like to show you some code that more efficiently describes the use and the workings of neural networks within the system. Okay, so here we have a function that trains the neural networks for classification purposes. As input, we receive either the spectrum training data or the frequency training data. The next step is to create a network, in this case using 20 hidden nodes. After that, we train the network using a target matrix as determined by a separate function which indicates which instances of each word should be trained to a certain digit class. After this is done, we can send as output either a trained feed-forward network or a trained pattern recognition network, which can be used for classification. And now we come to the genetic algorithm. This is succinctly described by the diagram in the slide. We start off with the initialization phase, then we have the evaluation, selection, crossover, and mutation phases, which are repeated as per a generation counter. Now, the genetic algorithm is based only on the frequency septual coefficient extraction technique, and this is because of the convenient sizes of the vectors as an output from the technique. So if we look at the function regarding the genetic algorithm, we start with a for that runs for a predefined number of instances for each class. Next, we have a while loop that iterates for a predefined number of generations. Next is the initialization phase, where we create a population of chromosomes, the chromosomes being the same size as the vectors gained from the extraction technique. Next is the evaluation phase. During the evaluation phase, we make sure that the chromosomes created are within an acceptable error range or Euclidean distance from the vectors of the extraction technique. After this, we move on to the selection phase. During the selection phase, the fitness of the chromosomes or the error rates are considered and they are ranked accordingly. The chromosomes with higher fitness rates are more likely to be chosen for the next step of the process. Next, we move on to the crossover phase. During the crossover phase, pairs of chromosomes are called to interchange elements according to a crossover rate parameter. We now move on to the mutation phase. During the mutation phase, random elements are selected within the chromosome in order to be mutated or changed. This is to improve the fitness of the said chromosome. Okay, here's a quick demonstration of how the program works using a file in which I set the numbers 0 to 9. Here are all the relevant options. Okay, in this case we can see the poor quality of the system without the use of machine learning algorithms. We can try with the neural networks now. And here we can clearly see the vast improvement. When we consider the results of the system without the machine learning techniques, you should notice the awful state of the frequency septual coefficients to the spectrum feature extraction technique. Next, we have the results of the system using neural networks. On the left, we have networks using the frequency septual coefficients extraction techniques. On the right, we have the networks using the spectrum feature extraction techniques. The top graphs are representative of feed-forward networks. The bottom graphs are representative pattern recognition networks. Finally, we come to the results of the system using the genetic algorithm. Here we can see a vast improvement for the system using the genetic algorithm over the system not using it. The system using the genetic algorithm is also superior to the neural networks based on the same feature extraction technique. However, it is inferior to the networks based on the spectrum feature extraction technique. In conclusion, we have seen how the machine learning algorithms vastly improves the accuracy of the system. In addition, it was noted that the capability of the machine learning algorithms improved as the training data sets increased. This concludes my presentation, and any further questions can be sent to the email address in the slide. Thank you for watching.